Hello, welcome to another episode of Under Review with me, Andy Tattersall. It's a beautiful spring day, although rather very cold. With this episode, I'm going to be joined by Professor Stephen Curry from Imperial University. Now, Stephen worked at Imperial for 30 years before taking retirement. He retains a position as an Emeritus Professor, and he continues to write about science and describes his area of expertise as figuring out the three-dimensional structures from which biological models and atomic detail using X-rays and crystals. Stephen has long been an active campaigner for the importance of engaging with the public and very much practiced what he preached with multiple outreach videos and articles in mainstream media. He was Imperial's first Associate Provost for Equality, Diversity and Inclusion, and whilst he's formally retired from academia, he's still active as a writer and a consultant through his Reciprocal Space Blog and as a scientific strategic advisor for the Research on Research Institute. He was the chair of the Declaration of Research Assessment, DORA, for 6 years between 2017 and 2023, which led to an invitation for him to speak at the meeting of the US National Institute for Neurological Disorders and Stroke, known as NINDS. This in turn led to a recent paper on publishing negative results, which is the topic we're going to discover and talk about today. And it's a topic that I didn't know an awful lot about, and Stephen covers a lot of ground in the next hour and talks about the importance of publishing negative and null results, and we get to throw a few things in the bin, and he suggests some fantastic ideas as how we can do science better. In this episode, we're going to also discuss publication bias, which is perpetuated by journals prioritizing positive results due to the impact factor pressures, and how that can be changed, among other things. We also discuss the importance of rewarding rigour over exciting results, viewing Francis Crick's own failures as valuable lessons. So without further ado, here's Under Review. Thanks for joining me today, Stephen.
It's my pleasure, Andy.
So we're going to talk about primarily negative and null results, but this is an opportunity for you to also think about other things within, your long academic career that's giving you insights and ideas as to perhaps the things we're doing wrong, which we see often in the academic workplace, and the things we could do better. But first of all, I want to talk about the paper that you published on this topic in 2025. First of all, I think it's important for people who are watching this or listening to this to have an understanding. What are negative results or null results?
Okay, well, so science proceeds in many different ways, but one of the main sort of processes that happens is that somebody comes up with an idea of how to explain a particular phenomenon. Why is the sky blue, or will this drug cure cancer, or whatever? And you then design a set of experiments with which to test that hypothesis. And if you can demonstrate results that are consistent with the hypothesis, then that's a positive result. But if you then find out, actually, my brilliant idea isn't panning out, so this drug doesn't cause cancer and the sky isn't blue because of the presence of blue particles in the sky, then you have a negative result. And so that's what would be regarded as a negative or null result. It's when your brilliant idea is, I think it was it J.B.S. Haldane put it, is destroyed by an ugly fact.
I like that. Do you think that, is there a primary reason, have you found this in your research, or something that you have your own hypothesis to as to why there's a primary reason that research that produces negative or null results just ends up in someone's desk drawer, never to see the light of day?
Well, there's a number of ways to explain it. I mean, I think psychologically, we're all humans, and although the philosopher of science Karl Popper would say that, the function of science is to try and falsify hypotheses. You can never actually prove something to 100% certainty, and therefore the function of science is to test and test and test. And we see, throughout history, eventually, theories do break down and are replaced by better theories. Newton's theory of gravitation has been replaced by Einstein's ideas about the warping of space-time by massive bodies. But of course, I never in my whole career set out to disprove one of my brilliant ideas. If I had a brilliant idea, I would try and design experiments to produce evidence that would support it, that would demonstrate that, yes, I truly am a genius, and this is the way it goes. But occasionally, of course, then you get a negative result, and well, immediately you're then thinking, okay, well, what's a different explanation for that? Can I come up with a different hypothesis? And so you're immediately, thinking of, okay, how do I get a positive result? Because it's, it's actually easier to publish a positive result. And so the whole area of scientific careers is really built upon establishing a track record of actually being able to come up with good ideas and to do experiments and then to get them published. And journals are generally not that supportive of publishing negative results because they're not as interesting as positive results. They're therefore less likely to be cited. And if that's the case, then that tends to have a drag effect on the journal's impact factor, which is a number that everybody knows is attached to every journal, which is basically the average number of citations that their papers produce. And of course, journals attract authors by having higher impact factors because we have a system of assessment of researchers that looks too hard at the impact factors of the journals that one publishes in. And so there is this kind of vicious circle whereby, even though, it's a very long-standing ethos that one ought to communicate the results of one's work, that's been around for hundreds of years, whatever the outcome, the mechanics or the economics or the incentive structures are tending to push against that. There are, of course, exceptions, and there have been experiments with things like, journals of null results and whatnot, but they haven't really flourished. And the paper that we wrote came out of a workshop that was trying to sort of address what's understood to be quite a long-standing issue.
And that paper that was published in PLOS Biology, titled "Ending Publication Bias: A Values-Based Approach to Surface Null and Negative Results." And you found the extent of the problem varies depending on discipline and field. Is there any disciplines where this is more commonplace?
We didn't look in great detail at that, so I can't really answer that. Most of the attendees at the workshop, which was run by the National Institute of NINS, Neurological Disease and Stroke. Yeah, sorry, I have to work out the acronym, which is based in Rockville, which is near Washington in the United States. And so it's part of the National Institutes of Health, and so it was mostly biomedical researchers that were present, but there were some people from other disciplines, economists, for example. So it's certainly the case that within biomedicine, which is one of the fields that does seem to be most obsessed with metrics, then that there is this there is certainly this recognized problem. But I think it happens in physics and in chemistry. In the humanities, I would be much less familiar with the situation on the ground, but humanities research is to a large extent not hypothesis driven, so there's perhaps less scope for this type of outcome.
So do you think what would need to change that would be a bold move by a particular group or discipline, and say the journals that have attempted to do this? We see this in academia where everybody kind of looks at what everyone else is doing and they wait and they watch. And we're seeing this at the moment with universities pulling out of Elsevier deals, etc., and such like. Do you think that would be a way forward where suddenly a group go, do you know what? We're not doing it this way. We're going to publish the negative stuff.
Well, you do need leadership in that way, and you need people to set the example or to set the standard. But one of the issues with the sort of the scientific community is there isn't actually any leadership. There's no de facto leadership. We don't have a president that we look to steer things or to say, look, folks, this is how we should do things. In the paper, we did sort of set out a framework, and we did suggest particular actions that different stakeholders could take. We looked at funders and institutions and also publishers and learned societies. Learned societies, of course, very often have their own set of journals. To my mind, I think one needs to look at what the funders can do with the levers that they can pull. We are reliant on funders, both public, like UKRI in the United Kingdom, or private or charitable funders like the Wellcome Trust. And researchers are dependent on them for funding their projects. And I think it would not be unreasonable for funders to stipulate that if you've proposed a set of experiments or a program of research, then we want you to report on every single thing that you proposed when you came and asked us for money. And and there are different ways that negative results can occur. It might be that actually the researcher, there was a certain work package and they never got around to doing it. The research evolved in a particular way, and something interesting cropped up that they wanted to pursue instead. And very often funders are good at giving people the flexibility to pursue what they think are the most promising avenues. But there might be an idea that was in the proposal that actually simply hasn't been tested. And so it would be useful if researchers could report, well, we said we were going to do this, but we didn't. The reason we didn't was we pursued this other line. Or if they did actually do it and got a null result, it didn't produce it, even if they then didn't publish it, they should be able to report in a very concise way to the funder, who can then put it on a public database, that they tried this, here's what they tried, and this is what they found. And require researchers to do that, to file those reports before they can then come back and say, please, can you give me some more money for my next brilliant set of ideas? And I think, funders, I think they do recognize that they have enormous power because they pay the piper and call the tune to a degree. And we have seen funders, change behavior in some ways. The drive towards open access publishing, which, many researchers were in favor of, but they were then also wanting to publish in, the high impact factor journals because that was in their own career interest, and that made it difficult for open access journals to get a foothold in the market. But funders were very influential in helping to shift that type of behavior. And so certainly in the UK now, pretty much all publicly funded research is open access. Now, one can go too far with this, and I think funders are wary about just laying down the law, and they often, of course, require the cooperation of the scientific community because they rely on researchers to do peer review and to sit on grant panels for them. And so there is a bit of a give and take. And I think one wouldn't want to be, introducing whole extra layers of massive bureaucracy to achieve this. And so, part of the proposal also was that clearly funders have to engage in dialogue with the community to work out, what are the most frictionless ways that we can do this. But I think if funders were laying down the law in that, saying this is a requirement, if you're funded by us, you must report on everything, positive or negative, I think they would, institutions would fall into line because they depend on their researchers bringing in grant money. That is one of the ways that helps to keep the good ship of research afloat. And they can support that by themselves making sure that, they are rewarding comprehensive reporting on your research, not just picking out the positive stuff and forgetting the other stuff. So that, they would have to sort of obviously cooperate, but I think we do see that in other areas, and that would be the main driver. I don't think you can rely on the journals so much. I mean, maybe some of the larger society journals, might want to set the standard, but but the trouble is, most of the journals that certainly in biomedicine these days, they are run either commercially for profit by a company like Elsevier or Wiley, but even learned societies, they're non-profit, but they generate enormous surpluses from their publishing activities, and so that's a very valuable income stream. So they do have a profit motive. It might be a slightly more altruistic profit motive because they plow the money back into the field, but nevertheless, they are still in the game and they are competing with the commercial journals, so they're under the same pressure. So I think they are, they'll fall into line if the funders say, well, we're not going to pay processing charges unless you're also publishing negative results and you can demonstrate that you're doing that. But I think ultimately it comes down to the funders wanting to take leadership. But of course there isn't, it's not as if there's within the UK, obviously UKRI is a very important funder, but it's not the only game in town. And across the international scene, of course, then it's very fragmented and different countries and may take a different view. So it is actually difficult to get leadership on this. You probably do need a concerted campaign, a number of champions to lead it. That's kind of what we saw with DORA, the Declaration on Research Assessment. It's been around for 10 or more years now, but it really relied on very strong, didn't require very many of them, but it just needed sort of very strong advocacy from a certain small number of very highly motivated individuals, one of whom was myself, to push that idea forward. But so it can be done, but it requires vision and leadership that we don't always get from the research community, but with notable noble exceptions.
We often hear about the carrot and the stick approach, and like you say, we can't go full stick because of academics are feeling overwhelmed by the bureaucracy and the things that they have to deal with now, and what they need is incentive, especially when the sector is under such pressure at the moment as we're seeing. So it feels like we need some kind of carrot baton with that kind of incentive there to say, look, here's the positives of the negative.
Yes, and I don't want to overstate the problem here. I mean, it's a well-known phenomenon that's out there, but I do think the vast majority of people in the research community are doing their very best. There are a lot of very smart people, and if they come up with ideas. And actually, one of the most important attributes is to come up with ideas and then to test them. And that, that's the, that is the kind of landmark achievement of this whole scientific enterprise, is that, we are prepared to test ideas and they will stand or fall based on the evidence. And there aren't many other domains of human endeavor. Politics, for example, is a very different from science. And within politics, we see how much influence and power one can win through the deployment of misinformation. And within the scientific enterprise, then there is an intrinsic value that values, it is evidence, and however brilliant your idea, if the data are telling you that actually your idea is wrong, then you will eventually abandon it. You might abandon it very reluctantly because, we all like to think that we have good ideas. And science thrives actually on being able to tear ideas apart. I mean, I have just read the biography of Francis Crick by Matthew Cobb. And one of the secrets of Crick's success, and he was very influential, not just in solving the structure of DNA, but in sort of conceptualizing the whole field of molecular biology and driving the work to crack the genetic code, and then moved into neuroscience. But Crick was always somebody who worked with other people, and often in pairs, either with Jim Watson on DNA, but then with Sidney Brenner on molecular biology, and with Christoph Koch later on neuroscience. And they were prepared to have really tough, frank conversations where they would come up with ideas and they would tear them apart. And often they would that would help them sift their ideas so that then hopefully only the good ones made it to the top. But actually, as the biographer makes clear, Crick did himself, occasionally publish stuff that was just, plain wrong or misguided and whatnot. So, even the best of us are not immune from getting things wrong. And I think, to frame it in terms of a carrot, I do think we have to recognize that most scientists, they care about science, and they care about it being done well. I mean, obviously it's a human endeavor, so there will be exceptions to that rule. But I think one of the ways that institutions can also help is by placing more emphasis not just on the sort of excitement that might be generated by a result, but actually really looking much more closely at the rigor with which that result was achieved and rewarding people for the rigor of their processes. So even if your brilliant idea turns out to be wrong, if you designed a set of experiments that very clearly show that that is wrong, then you should be rewarded for that. You should be recognized. You should never talk yourself out of an experiment, is what I was always taught. And I think that's a good maxim to live by. But it does mean that occasionally your experiments will destroy your hypothesis, but that's good. And actually, if you then publish that work, then that means that, someone else will say, oh, this idea has been tested, I don't need to do it. Or they might look at your account and say, oh, well, Curry made a mistake here. And actually, I know a better way to do this experiment. And actually, I think the idea still has legs. But if we analyze it this way, or if we design experiments in this way, then we can do it. But that's you're obviously feeding the machine that way in a positive way.
Well, this podcast is called Under Review, so we throw things in the bin. You've given some positive ideas, things that we can do better. Can we put Crick's poor papers in the bin, the ones that he shouldn't have published, and any others that people?
No.
You're going to keep those?
Shouldn't put them in the bin at all, because it even shows you that the people that we revere as geniuses, and Crick was one of the most outstanding scientists of the 20th century. There is no doubt about that. But it's important that you see that actually even someone like Crick, with everything that he achieved, he still comes up with dud ideas from time to time, and that is a totally normal part of the scientific process. And so I don't think we should go back and censor it, or that's like eliminating Trotsky from photographs and whatnot. We don't want to sort of polish history. Science is a very human endeavor. It has achieved many great things, but it has made many mistakes along the way, and that's a totally normal part of the way it operates.
Do you think that's the great anxiety that we all have? Along with imposter syndrome, it is the fear of making mistakes. Yet as students, we're taught to make mistakes. When you go and do your first undergraduate degree, you are failing continually and learning and being taught how to change. And then when you build up through the ranks, you're dealing with failure, you're dealing with rejection, but you learn from that, surely. So
yes, no, you absolutely do. And often anything that you do in life, if you fail at it, it's often a much more powerful lesson than succeeding all the time. Because actually, if you succeed all the time in life, then when you do come up across, in face of a genuine problem, then you will struggle. And it's really important to learn that you can fail, and that failure is not the end of the world, and it's not the end of your career. And you just pick yourself up, you say, okay, I screwed up here. This is what I did wrong. I overlooked this, or I made a mistake here that I didn't recognize, or I was too keen to sort of believe the data supported my hypothesis that I didn't, I kind of disregarded these slightly anomalous observations and whatnot. So learning from mistakes is a very important part of it. And it is something that is important to teach to students, but actually it's very hard to teach this to students. Okay, and I experienced this, at university. We did struggle a lot of the time. We tried to introduce occasionally lab experiments where the outcome was not determined. An awful lot of undergraduate teaching and science experiments is basically there's a recipe, and if you follow the recipe, here's the result that you will get, which is a completely fake idea of science, because science, there is no recipe. You have to sort of make up you have to invent the experimental procedure, and you don't know what the outcome will be. But actually, students don't really like it if they don't know whether they've got the answer or not, because that's the way that we train young people in school. They do exams, and there's a right or a wrong answer. And if you get the right answer, then pat on the back, off you go. And people who have been very successful academically, it can be a bit of a sobering experience to have something. And of course, universities are under pressure now to give students a universally positive experience, because students fill out surveys that are then factored into league tables. And so there's an awful lot, and quite rightly, universities should be looking to give students a very rich experience. But I did, I was admissions, or I was director of undergraduate studies for a while, but I do remember talking to school leavers and saying, if you're just coming here to get a piece of paper with it says you've got a degree on it, then please go somewhere else, because we're going to stretch you, we're going to make you uncomfortable. And, there will be things that we do that, we will do things that make you uncomfortable, within the bounds of, what's legal or whatever. But but that's useful, that's good for you. Because it's important to stretch yourself and to find out where your limits are. So that is, it is quite hard to teach, but it is an important lesson, and that's why we should make sure that Crick's misfires remain in the literature, so that people can then learn from them. So those are perhaps some of the most potent lessons, but there's nothing more potent than making a mistake yourself and dealing with it.
And do you think the problem regarding the reluctance to publish negative null results is got worse because of how research is communicated, how it's shared? It's often sensationalized because of the rise of clickbait and the media and how they want to sell newspapers. And so journalists portray research often in a way that academics aren't totally comfortable with.
There's some truth in that. For the vast majority of science, their work never gets into the press. Okay, so I don't know that I ever had a newspaper story about any of my, maybe in the trade press, whatever. But I was always more pleased that the results got into textbooks rather than newspapers, shall we say? Newspapers, of course, they like a good story. But actually, often, if you look at the sources of those stories, it's often a press release from the university. And so it's not that the newspaper, the journalist is over-egging it. Often the university is over-egging it a bit in order to get the media attention. And it's better actually. Often, of course, if responsible newspapers will actually then go to a third party and say, if you read this paper, they say it's the next best thing since sliced bread. Do you think it is? And so responsible journalism will do it well, and there are many good examples of responsible journalism, even in the UK, and even in outlets that you sometimes might be surprised at. I've seen very good articles about science in the Daily Mail, for example. We used to teach this to our undergraduates, and we would get them to pull out examples of stories. Some of them, they sensationalize a study that's based on, testing something on, 75 people or whatever, which is, of course, a very scientifically suspect thing to do. So, there is good and bad. But the reluctance to publish negative result, it is partly because, there aren't the incentives there. You won't, at the minute, you probably don't feel you're going to get rewarded for it. And if you are trying to sustain your career, and, every rational scientist is trying to do that, then you'll basically be turning your attention to, okay, well, what's the next thing that I can do that will get me a positive result? Okay, this one might have crashed and burned, but what direction does it point me in? And you want to start working on that rather than then spend time writing up the negative result, because that's, there's an opportunity cost there, and scientists are, on the whole, very rational people.
And the term negative results can give the notion the work is of disappointment or waste of time, but isn't the real failure in the huge sums of sums in funding wasted by scientists unknowingly repeating experiments? So they're going and doing this work, not realizing that it may have actually happened multiple times, sitting in desk drawers, and somebody's already proved that this didn't work. So that's a lot of money going to the wall.
I think yes, and I think that's part of the, so actually a commitment to publishing negative results should be part of the process of ensuring that we retain public trust. I mean, I think in the UK, there is actually strong public support for researchers doing what they do, and actually even doing, curiosity-led research that is maybe a little bit abstruse, doesn't have any immediate application, although, well, things seem to be changing at the minute, but doesn't directly, contribute to economic success or economic productivity. But I think, an appreciation that, part of that work is funding things that don't work from time to time, because we cannot, and if you're only ever going to fund things that you think are definitely going to work, then you're going to trap yourself in doing incremental things and not really fund the more risky breakthrough discoveries that are ultimately, very, very difficult to forecast and to predict. So I think, that transparency with the public on this front is really important. And I think, the whole publishing, the whole approach to publishing, it is kind of scandalous in a way, because we know that you get rewarded for publishing in the top journals with the highest impact factors. And so what people tend to do is they submit their paper to Nature and it gets rejected, and then they try, Nature structural molecular biology, next one down, and it gets rejected there. And then they work their way down. I mean, I used to do this myself. The worst I ever did was 5 journals for a piece of work that I thought was, really solid and interesting and an important piece of work. It was on the structure of an enzyme from foot-and-mouth disease virus, which I thought was very important to the UK. But anyway, the editor of the various journals disagreed with me. But what I did by doing that was, I spent sort of 6-9 months, holding back a result that could have been shared with the scientific community, because I was chasing after an impact factor. And I met a fellow at the Royal Society a few years ago who told me that she was on her 10th journal for a piece of work that she felt was among the best that she'd ever done in her career, but she'd spent 18 months not publishing it. And so I think if the public knew that we were holding stuff back because the incentive structure means that, for my career advancement, it's important that I publish it as well as possible, then actually what we see is that our incentive structure is misaligned with the public interest. And yet, the vast majority of us are doing work that is largely funded by that public. And so the same applies then to negative results. It is important to say, okay, I had a brilliant idea, but actually I did a very careful set of experiments. It shows the idea has no legs, and it's therefore important to make people aware of that. And I don't think anyone's ever been in a position to calculate, well, how much money is being wasted when that's not happening, but clearly some. And if we can, these reports don't have to be lengthy and time consuming. But if we have mechanisms and outlets that enable people to get them written quickly and then get them out there. There was some debate in the workshop we had about whether or not they should be peer reviewed. And my feeling is that you just, you publish it as a preprint, which is not peer reviewed. Now, you clearly mark it as peer reviewed, but clearly experts in that field will be able to look at it and say, well, they did this well, or they didn't do that well, but so I can therefore pick this up and maybe get it to run. So, and that again, because if you're expecting everything to also be peer reviewed, then of course that adds to the workload burden for the community, not necessarily for the individual researcher who produced the negative result. So one does have to be mindful of all of these sort of interlocking factors.
I can imagine there's only a matter of time, if this hasn't happened already, where there's somebody who's done some research, they've left it unpublished in their drawer for 10 years. Someone goes and does the same experiment, gets the same results, publishes it, and then gets some form of plaudit. And there's an academic sitting there going, oh, that was my idea.
Well, they might do, but whether or not they'll actually come forward and say that publicly, because they will look a bit of a fool, is another matter. I don't know. Often, there are hot areas in research, and often you'll see in journals, you'll see the same result coming from 2 or 3 different labs, at the same time, because they've all been working on it, and that's because people gravitate to hot topics. And
absolutely, we see it in the film industry where they produce 2 films about the same person in the same year, where you feel like, well, did they know that? They probably knew that it was just happening, but they were both committed to it.
I guess by that stage, yes. I don't know how, it probably took several years to get the money and the actors and the director and whatnot together. Yeah, that happened with Capote, wasn't it? And that was
Truman Capote.
And Philip Seymour Hoffman got the Oscar, and poor old Toby Jones was ignored. But but he's an amazing actor himself.
So this may happen in academia. And going back to the trust issue, we have the Ipsos Trust Veracity Trust Index, and scientists always rank very, very highly, journalists very low, along with politicians. So you feel that this would help with the trust element, that the understanding, because we saw a lot of this around COVID. There was a whole debate around follow the science people, and then the whole pushback from the conspiracy theorists, other people with their own agendas, and science became a little bit of a kind of it got a bit of a kicking at times over COVID. And do you feel that we needed to explain more? I think Chris Whitty tried to do this, and they tried to explain, the science does change. We can say this one day, but we can't say it the next. And society needs to have a better understanding of that. Do you feel that this could all be helped?
I think yes, absolutely. The transparency is non-negotiable, I think. So one does want to present negative results as they come out, because if you're not presenting them, then of course you're hiding them, and that's just grist to the mill for conspiracy theorists. But it is true that there are many bad faith actors out there, and the COVID pandemic was a case in point, and that was unique, certainly in recent experience, because you had a major scientific problem that was playing out in real time, and in the middle of a pandemic when the information was absolutely required. There was uncertainty right at the beginning about whether or not wearing a mask, for example, was or wasn't an effective measure to take. Ultimately, it turns out, there is a benefit to it or whatever. It doesn't necessarily protect you as much as you might think, but if you're carrying COVID, then you are transmitting less viral material if you're wearing a mask. So at a population level or in crowded areas, then there is a benefit. But people didn't know. Of course, there's a long history of vaccine skepticism, stirred up certainly in this country, and of course we now see it in the United States. Absolutely. Tragically, you have a character like Robert F. Kennedy Jr. in charge of the health service, and you see measles on the rise again, in that country, and so one does need to be mindful of the fact that these things are going to play out. But it is about the scientific community standing up and saying, okay, here's the experiment we did. This is what the evidence means, and it means this. It doesn't mean this, and then to there are arguments about whether or not you should go toe to toe with conspiracy theorists who are so far out there that they're just simply not in touch with the sort of scientific mainstream. But I think you want to pay attention to how much influence are they having, through social media on particular constituencies and whatnot, because that is clearly a big challenge, and I don't think there are easy solutions to it. But honesty, transparency, and comprehensive reporting, I think, have to be our bedrock in approaching that.
Yeah, and I think there's much to be gained between the connection between the journalists, the media, and the scientific community to maintain a good, healthy relationship between certainly the media that don't have an agenda. We know there's parts of the media that will have an agenda regardless, but I think because the journalists benefit from this, surely they're the ones who are down that trust index,
Yes, I think so. But it is, with the best will in the world, accurate information will be misused or will be ignored, or because as we've seen, there are plenty of bad faith actors out there, and who will then make a big play of, well, last week the scientists said this, and this week they're telling us this, so what will they tell us next week? And so it's easy to play a sort of simple narrative. And I think the story that actually scientists need to be telling is that things do change. That's part of the normal. Science is a body of knowledge that is changing and evolving as we get deeper and deeper understandings of things, and we realize today that actually ideas that we've carried with us for 20 years are actually not quite right, and that's normal. And the vast majority of negative results are not produced by journalists or politicians. They're actually produced by other scientists. And so the community that is working hardest to demonstrate the rigor and the integrity of scientific evidence is the scientific community. And even when things go wrong, and there are many scientists and researchers engaged in, you know, trying to reform the incentive structures, you know, that's happening internally. It's not like Liz Kendall, the minister, is saying, you know, science really ought to get its act together. You know, the driving forces from within the scientific community because of this, you know, shared ethos. I mean, there will always be transgressors in any professional body, but the vast majority of people are really, you know, trying to do a serious and sincere job.
Absolutely. And you've touched on some of the solutions, talking about what funders could do, how they could be more involved in this. And your paper mentions previous attempts to fix the issue around the reluctance to publish. And what you've said is that they're fragmentary and largely unsuccessful. Has there been any solutions that you've seen that you've not already mentioned that have potential?
Not many. I do think, you know, the funder role is key. And it probably does need more of a sort of campaigning activity on the ground to really push this forward and to, you know, get it into the agenda, and maybe, you know, to get a bit of public support, you know, behind it as well, for ensuring that we tell the whole story and that people are rewarded for the rigor and carefulness with which they do the work, not necessarily for the outcome. You know, that's what we, you know, that's what everybody would want from every single scientist, is actually, you know, the highest degree of rigor and the quality that they bring to their work. And too often it's the, you know, the glitziness of the result that is what is rewarded. And of course, you know, we're all human. I mean, you can't fail to be excited by exciting results. You know, the development, the very rapid development of the COVID vaccine, for example, was just a tremendous testament to a huge body of absolutely fantastic research, starting, you know, 20 years ago with, you know, trying to figure out, you know, the technology behind mRNA vaccines and whatnot. So it's, you know, it is a deeply systemic issue that probably has to be tackled from multiple points. I think it has got easier to publish negative results because we have seen the rise of preprint servers and taken up by, you know, quite a number of different fields, been in many subdisciplines of physics for a long time, but has obviously come into the biomedical sciences more recently with bioRxiv and medRxiv, and one sees it also in the social sciences and economics as well. So that's, you know, a relatively frictionless way to, you know, you can write up your paper and you just hit submit and it's published. And we also have, I think particularly, I guess, in the biomedical sciences, these mega journals, and like PLOS ONE and Scientific Reports, I guess, are the two biggest. And they have an editorial standard, which is that, you know, is the work, is it new and has it been rigorously done? And it doesn't, you know, the excitingness of the result is not a factor in the editorial decision. Actually, these are, you know, people do publish an awful lot of work in this. Sometimes the peer review seems to fail. There's been a few notable cases, but again, that's a relatively cost-effective way to, you know, get your work out. Although I did have an example because I wanted to make a point, and we had a negative result in our lab about 10 years ago, where we had an idea about how to engineer a protein so that we could study the way that it interacted with its substrate in a particular way, and it didn't work at all, you know. So we tried like 4 or 5 different ways, and all of them failed. And we actually wrote it up for publication, partly because I had a couple of undergraduate students who'd worked on it, and I wanted them to get a paper out of the work. And we submitted it to PeerJ, which is one of these mega journals where, you know, it doesn't matter about the outcome, as long as you've done the work carefully and it's a new finding. And I very much wanted somebody else to, you know, see what we'd done, and maybe if they had the funds and the energy and the time to pick it up and run with it. And the reviewers came back, and I, even in the abstract, I said, this is a negative result, you know, but the reviewers came back and said, oh, try this or try that or try that. And then, you know, maybe it should be accepted for publication. And I kind of thought, well, you know, the undergraduates, they'd only been in the lab for a couple of months and they were gone, and I didn't have any money, or I didn't have anybody to work on it. Unfortunately, I did explain it to the editor, who understood what I was trying to do, and they did publish it. But it shows you, actually, sometimes even with the best will in the world, when you're trying to publish a negative result, then people will say, oh, well, you should do this whole other set of experiments, and maybe then you'll get a positive result. So there is something in the mindset of ourselves as reviewers where you maybe struggle to accept a null result or a dead end, whatever.
Yeah. And you've suggested a value-based approach to system change, but we still live in this publish or perish world. And of course, those values don't pay the rent. So how would you convince a worried PhD student who's starting on their publishing career and they've got this negative or null result, and it is going to be a good paper, but they're worried that it is going to be a bad start to their career, how people might perceive that?
First of all, I wouldn't put it on PhD students to solve a problem that's been around even before they sort of got into the lab. I do think it is for the more established researchers to try and set the standard, and to help the PhD student publish the result and get it out, and to make sure that people know that yes, it's a negative result, but actually it's a clear negative result because the work was done so competently and so well. And so, here is somebody, okay, that maybe didn't get a high impact paper. It's a negative result. It's probably not going to garner very many citations. But then, when the PhD student is looking for their next job, the principal investigator or their supervisor, they can put in their letter of recommendation, about the quality of the work that you can expect, from this person. There was a celebrated case when the cell biologist Randy Sheckman was awarded the Nobel Prize, and on the day that he was due to get his prize in Stockholm, he announced that he and his lab would no longer publish in Nature, Cell, or Science, because he felt that the obsession with so-called glamour mags was ultimately harmful to science. And he was immediately accused of being a massive hypocrite, because he was just about to get a Nobel Prize on the back of a CV that was stuffed with, Nature, Cell, and Science papers. And people did say, well, what about the young people in your lab? What's going to happen to them? And so, but I do think it was a brilliant stroke of PR, because it got lots of press attention. But also Randy Sheckman, being a Nobel Prize winner, he can write a very authoritative letter of recommendation. He can explain, the reason there aren't Nature papers in my student's CV is because that's the policy of the lab. But, I know what I'm doing, and I can tell you without doubt that, this is an excellent researcher. This is the quality of the work that they produce. And so it is down, I think, to senior figures to take responsibility and to take the risks for for changing the system. I would like to have seen a few more Nobel laureates follow Sheckman's lead, but of course not a single one has that I'm aware of. And so that just shows you the power of the hold that these journals have over the scientific mindset. So it is a deep-seated problem, but it is changing.
Everything can change. It does over time. And do you ever perceive a time where, and I don't know if this is even possible, where a negative or null paper is treated as an impact case study? Because that's the thing that often a lot of academics are looking for, and what they're hoping to get is to be part of an impact case study. The ref brings them a lot of money.
I can certainly see some examples. I mean, if you think back, for example, to the concerns that were raised about the safety of the MMR vaccine by Mr. Andrew Wakefield, no longer a doctor. I'd like to think he'd been stripped of his PhD as well. But that created an awful lot of uncertainty. I mean, there had been pre-existing work which didn't show any link between MMR and autism. There were subsequent studies that, again, confirmed the absence of a link, and that's therefore a negative result. And those were very important pieces of work to try and help restore trust in the MMR vaccine. I mean, we still haven't got back to where we were or where we need to be, because we don't have vaccination levels at the level required to get immunity. So we don't have that protected status. And of course, you see measles on the rise in the United States, because Kennedy and Trump and whatnot are casting all sorts of doubts, completely unfounded scientifically, about the safety of these vaccines. So in those sorts of situations, then a negative result saying, no, it's not harmful, but it's still okay. If you're pregnant, it's still okay to take paracetamol. It's an effective remedy, and there's no evidence that it's harmful to the baby. So those cases, I can certainly see that might fly in terms of an impact case study.
They're great examples. I think we can definitely put Mr. Wakefield's PhD into the under review bin, can't we?
I would certainly enjoy doing that, yes.
And any policies that Robert Kennedy Jr. comes up with, because it's interestingly, as you say, measles cases have been on the rise in the US. And this has led to Kennedy saying things like, well, maybe we should have some research into a measles vaccine. You can't, the irony is totally lost on these people.
Yeah.
It's a very, very dangerous situation.
It is extraordinary, and it's people will die thanks to Kennedy. He will kill people. There's no doubt. So it's a horrific situation for the American population.
If we were going to fix publication bias, are there any specific academic status symbols that need to go into the under review bin?
Well, the impact factor for one, obviously, I think you might expect me to say that, but I think and the impact factor is an example of an aggregate metric. So it's the average citation performance of papers within a particular journal for the past couple of years. But work that we did, and it's 10 years old this year, shows that, and well, it was hardly new, but it shows that the citation performance of papers in all journals is, varies over an enormous range, 2 or 3 orders of magnitude. And so the impact factor is actually heavily weighted by a relatively small number of papers that do really well. But there are, more than half of the papers in Nature, for example, get fewer citations than is indicated by the impact factor, but we treat them all equally. And of course, citations vary for lots of different and quite benign reasons. They vary enormously between fields, because some fields are bigger than others. I see that with my own papers. I have papers that I've written where I would consider them to be, of equal value, but one is more highly cited because it's in a field where there are many more researchers who can cite it. But it's just taken as an aggregate measure, and every paper in that journal then benefits from the impact factor. And the same I would apply to the scores that are used to determine university rankings. These are aggregates of people's opinion about the university, staff-student ratio, grant income. Some of them, they just simply count how many papers have they published in Nature, Cell, and Science, in 3 journals, and then they add up these numbers, they give them an arbitrary weight, there's no justification for it, and they come out with a number which is quoted to 3 decimal places, and then they come up with a ranking. And there's so much information is discarded in that very simplistic process. And I have to say, there are a great many universities who they kind of demean themselves by, talking up the fact that, oh, look, we've risen 2 places in the rankings, and just the total absence of critical thinking about what a change of a few positions in a university ranking actually means. Now, universities are enthralled to them because students look at them. That's the problem. There is a market incentive problem there, so they can't do it. But I do wish more universities would actually have the self-respect and integrity to say, look, we're not driven by these things. We might perform well in the rankings, but that's a byproduct of the fact that, we do fantastic research and we are great at teaching students. We give them a very rich experience, but I think too many of them, their strategy is all right. Okay, how do we increase our score here? And because, in the Times Higher one, it's something like 35% of the score is just people's opinion about the university. And I don't know. I mean, I spent most of my life at one university. I couldn't really tell you about, how things work in, more than 2 or 3 other universities where I spent some time. And yet there are people who fill out these surveys, gladly. And it's completely useless information,
And,
so.
and they They cherry pick as well, don't they? There'll be a huge media furore when they've done well. They've gone up a few, and then everyone says, "Say nothing, go quiet."
Yeah, and probably they look at the last year's league table to see, and everybody's heard of Harvard and Yale and Caltech and Oxford and Cambridge and whatnot, but you haven't heard so much of the University of Northampton or some of the universities that are actually doing a fantastic job. And one of the troubles with university rankings is they're holding everybody to the same standard. It's how good are you at doing world-class research on the international stage? And there's a small number of universities which clearly do very good work. My own institution, Imperial, would be one of them. It's a very good institution, lots of fantastic people there doing great work. And it is, lots of international collaborations. But actually, there's many other universities. Northampton might be one of them, Hull or Huddersfield or wherever, where their primary focus is on serving the local community, and maybe an awful more of their research is geared towards addressing national or local issues and whatnot. And that's an incredibly important function, but it's very different, and it's not one that will score well on a league table that's configured to sort of allow the Caltechs of this world to sort of show up all of their wares. So it's a very non-level playing field, and yet everybody has to play it.
Yeah. So the rankings go into the under review bin. I think there has been a couple of universities. I think one in Belgium that have stepped out of the rankings, said that they're
yes, I think it's either Ghent or Ghent. Yeah, Ghent in Belgium. Yeah, in the Netherlands too. I think the University of Utrecht also has decided to secede from them. And yes, those are notable exceptions, I think. And there's a very good initiative which is led by, I think, by INORMS, which is an international organization for research managers. Lizzie Gadd, who's someone you should maybe get on your...
Lizzie's already agreed to be a guest.
Okay. Oh, good. Okay, so they came up with this initiative, More Than Our Rank, which is about, actually saying, we're much more than our rank. The university ranking is just a number at the end of the day, and actually the universities do so much more. And so we shouldn't be relying on these, simplistic aggregate measures for judging the quality of an institution.
And one of the things you said earlier was the fear, the reluctance to publish because of the lack of citations. Another metric here is the H-index. Would that go into the bin as well?
Well, the H-index is yet another aggregate measure that is pretty useless. What does it tell? It usually tells you how old a researcher is. That's roughly a measure of it, and it is traded, again, rather unwittingly by many people. They don't really understand what the H-index is. I did once have a conversation with the guy Anurag who runs Google Scholar, and I said, well, can't you just put in a button where people could see the distribution from which the H-index is calculated? Because everybody has a few papers that are very highly cited, but then the curve, declines, and then you've got a tail end of papers which only have a handful of citations. And I kept as a slide I use in my talk, but actually I would defend papers that occur all the way across that distribution. I'm very pleased with my high performers, and I think they perform well because they got a lot of attention within the field, and some of them have now, they're cited in textbooks, and so it's a significant advance within that particular field. But then there's others that are also cited in textbooks but have 10 times fewer citations because actually they're in a field that is much smaller than the other topics. And then there was my one with my undergraduates, which is a negative result, which again, it's got, I don't know, 3 or 4 citations, hardly anything. But I'm very proud of that, and I think it was an important contribution. And if I was asked to defend it in an interview for promotion or a job, I think I would do a robust case. And I think everybody could probably tell a similar set of stories about the work that they've done, and that they are actually justly proud of some of the papers that are not necessarily very highly cited. And we also know, of course, that citation rates correlate with the impact factor of the journal. So, you'll get more attention if you get into a high impact journal, and it's not, the quality of the work is not determined necessarily by the number of citations. And it's quality that we want to be assessing, not this numerical measure that it can mean a whole range of different things.
Do you think that some metrics would be better treated if they were just an indicator? Like alt metrics are an indicator of something. They're not a hard, fast. If you drill into a lot of these metrics, you can find a different story. And what you find is researchers say, I want to know my H index. And of course, you look on Web of Science, Scopus, other platforms, they're all different. And like you say, they don't tell the full picture.
No, they don't. And well, there has been an argument about the terminology. I mean, I think they should more often be called indicators and not metrics, because they're not, what do they actually measure? I mean, the impact factor is a measure of journal citation performance. It's a measure of that. It's an average, so it's not calculated in a very clever way, but that's what it measures. But what does that tell you about the quality of the article by Blogs et al., which was published in 1974? So the trouble is that it is used as a shorthand. People are busy, and so making judgments about people's track record, that's quite a bit of work. And so that's why I think we've become to rely more and more on so-called metrics. And metrics or indicators, being numbers, they have this patina of objectivity that people think, oh, well, that's more important than some subjective opinion in some letter of reference or whatever. But of course, they're not strictly objective, because every single citation is a result of a subjective decision to mention that particular paper rather than another one. And so, but we too quickly or too readily forget that. It's system one thinking, and we need a lot more system two thinking, I think, where you kind of step back and say, well, hang on a minute, what are my priors here? And, shouldn't I think about this a little bit more deeply and a little bit more holistically?
So as part of this recording, you get to be in charge. You get to be in charge of the whole of academia. You get to turn the switch off and turn it back on, and you get to implement something that will change how we've been doing things in the past, to do it differently. You may have already made suggestions as to how we would do that, but in terms of making null and negative results, bringing them into the kind of the fold a little bit more, accepting them with welcome arms, what would you do to get that to happen?
Well, I would go back to this idea of getting the funders to say, if you propose a whole set of experiments in your proposal and we give you the money for it, then you report back on everything, even if the result was negative, or even if the result was, or even if you didn't even undertake the work package to begin with. So, because then it's clear to the rest of the community about what's been done and what's not been done, or what has been tried and not worked. And I think, the power and the influence that funders have, then that is the thing that would move the needle on this, very long-standing problem.
And how would we restructure research to reward the person who proves their hypothesis wrong?
Well, I think, that is happening already. I mean, through the work of organizations like DORA, the Declaration on Research Assessment, which was trying to sort of push the idea that if we are doing assessing whether or not a piece of work is very good, or whether or not a researcher has a good track record, that you actually have to look a little bit in detail about what it is that they've actually done, rather than say, well, I published 3 papers in Nature and 5 in this other journal. The narrative CV, which is a tool that's now used more and more in research assessment, is a way where the funder or the institution, whoever is using that tool, can ask questions that are relevant to their mission. And so if you want to get an idea of someone's track record, you get them to say, well, tell me what are your 3 or 4 most important papers, and tell me why they're important. Don't say it's important because Nature published it. Okay, say it's important because it changed the thinking in the field about this particular idea or phenomenon, and you can see that it's been cited here and here, and so lots of people have built upon the work, and so it has been a very influential idea. And so that's a format that allows you to drill into the actual contribution, because also, in the biomedical sciences, most papers these days are multi-author. So you might have your name, you might be the author of a Nature paper, but you might have done very little towards that. Maybe you contributed a reagent that was used in the experiment in figure 10, but you got your name on the paper because you said, if I give you this, I want my name on the paper. Not terribly ethical behavior, but but it happens. But and so if you have a paper that you're very proud of, say what was your contribution, because you might be a very good person at jumping on other people's coattails, and that's how you've built up a very strong CV. Or you're, genuinely committed and somebody who can come up with bright ideas. And you need to be able to probe that. And you don't get that sort of information from just looking at the numbers. I mean, the numbers can tell you so much, and I wouldn't object to people saying, I'm very proud of this paper. It's been cited 500 times, and this is why it's been cited 500 times. So we want to give context, and so that kind of tool, it's a lot of funders and institutions are now experimenting with it. It's not entirely problem free because, of course, people are writing a narrative. There are some concerns that maybe it will disfavor people for whom English isn't the first language, but I think that can be overplayed a bit because we're all used to working with people for whom English is not the first language, and you can easily make allowances, I think, for the fact that they may not write idiomatically exactly the same way that you would. And I think when it comes to interview, you can definitely probe whether what somebody's written is then bullshitting or not. So there are definitely ways around those particular concerns. So, and I think you get a much richer picture. And we have to remember, at the end of the day, a piece of work it's a human endeavor, and so and we have to make judgments about it because there's only a certain number of jobs in the world, and there's only a certain amount of grant money. So, and one of the outcomes of doing research assessment well is that people don't get jobs and people don't get grants. But you want to be able to say, well, we did look very deeply at that. It's not like we did a superficial job. And of course, it's in universities' best interest to hire people that they think are, have qualities in the round. They're great researchers, but they're also, devoted teachers. And that is not just that they just do the research and, well, they might do a few lectures, if you really force them to, but they'll do them unwillingly and not very well. So you clearly want to have a happy ship and to be hiring people that you have a really good understanding of. And we don't get that from just looking too hard at the numbers.
Absolutely. And finally, is there anything that you would like to chuck into the under review bin? Things that you don't like, that not necessarily to do with negative null results, things that you just think are detrimental, problematic, we could live without. Now's your chance to say.
Well, I've already indicated a number of aggregate metrics that I think, but the trouble is, I'm fairly pragmatic, I think, in my approach. So even if you got rid of impact factors, they would come back in some shape or form because people do want quality. And within their discipline, I think there is certainly always going to be a motivation to create a journal where, they publish really high quality work. But of course, that would be better if part of the quality assessment was on the rigor with which the experiment was done, not just thinking about the shininess of the outcome. So I don't know. I mean, I'm more of sort of philosophically inclined to think, okay, well, where are we? And what can we do that's realistic? I'm not really a revolutionary type saying let's throw this out and start again, okay? Because that doesn't really happen very often. You don't get that sort of disruption in systems, but you do get evolution and you do get new practices that arise because actually people think they're a good idea, and so I would definitely I would ban impact factors from CVs, but we're seeing that's happening a lot. And move towards this more holistic assessment. But I'm more pragmatic. It's about taking steps forward rather than thinking, okay, we'll start again at year zero, a brand new work. Because that's not the way the world works, unfortunately.
No, absolutely. So see more of a sort of like a narrative approach to such as CVs, etc. Get a better understanding of that person.
Understand the context, so you might of course use quantitative information if it's there. That's part of the mix, but keep it in its place. And I think too often the quantitative information takes over or grabs all the attention because people see it as objective rather than subjective. But we're all making subjective decisions all the time, and I think we need to be honest about about that, and about the limitations, about the fact that, you know, we will make judgments that are wrong from time. Just as scientists get things wrong from time to time, then people making these assessments, we will get it wrong from time to time. But that, I don't know of a way to make a perfect decision-making machine. So
we're human, aren't we, after all?
we are, and then we're all subject to biases, great or small. And we're aware of many of them, but probably not of all of them, or, you know.
So I think key to this, the kind of in summary, key to this is that we need to learn and accept when we're wrong, put our hand up, and it to be accepted, because we do live in a world now where politicians never admit they're wrong. They double down.
Yeah.
People see that now. It's sort of spread throughout parts of society.
Yes, it is very unhealthy, and there is an aspect, I think, of, you know, cancel culture, which I don't really want to get into the culture war thing, but there is a certain intolerance, I think, in a lot of our public discourse that we do need to try and put a rein on. You know, people aren't given the freedom to make mistakes, and actually science can, I think, you know, shine a light here by, you know, by showing that, you know, if people make mistakes, if we publish negative results, then we know that even the brightest minds have feet of clay from time to time. You know, they will crash and burn, but you know, it can still be rewarding to do so.
Absolutely. Well, it's been a pleasure talking to you, Stephen. Thank you for your time. Got some good ideas there.
All right, thanks, Andy. I enjoyed it. Yeah.
Thank you very much.